Now there's a slight subtlety to this, and it's basically to do with the fact that you can have type hierarchies on exceptions. So let's just clear pretty much all of this down apart from the date part, and let's do something like this. And we'll say the error message is could not parse the data item. So if we run this now, everything will be fine, which it is. We get the date parsed, and if we have some kind of weirdness to the date and then we run, we're going to get this message could not parse the data item, which we have in this case. Okay. Now let's create a new method. Actually, we'll create a new method in a utility class, which is something you normally do when you're programming. You create utility classes where you can dump any methods there that are so general they don't belong to the concept of a specific class or whatever. So let's just say we've got a class called utils, which are just general purpose programming methods we might create during the course of our programming a larger project. Let's say we have a method here, public static string. Let's call it parse planetary body. Sounds very grandiose. I'll explain what that means in a second. But yeah, a planetary body, let's just say it's sun or moon. So we're going to take in a string, which is sun or moon, and we're going to return a sun or moon back. And actually, do you know what? Let's make it an enum, just to mix it up a bit. An enum is a data type that can just take fixed values. So let's do this here. So I did Alt and Enter, or Option and Enter, create enum planetary body. That package is fine, just hit OK there. And let's just say we have two options here, sun and moon. That means that planetary body, if you're returning from this method, you return it like planetary body can either be sun or moon like this. And it's nice because it means that planetary body is a data type that we defined that can only have a fixed set of values that you define. And that's the point of an enumeration. But anyway, going back to the exception handling aspect, let's assume that we have if sun equals ignore case body return sun, else if moon equals ignore case the body return the moon. Notice as well I just started typing in the capitalized version of the enum value and it automatically put in the fully qualified name. It's nice. IDEs can do that kind of thing for you, just to save you a bit of typing there. Then we're going to return planetary body.sun. If they've typed in moon, they're going to get planetary body moon, and we're going to throw a new planetary body unparsable exception, for example. We don't know what. So supposing they pass in Saturn here, for example, or Marmaduke or banana, whatever, it doesn't really matter, or penguin. By the way, if it's not one of these two discrete types, sun or moon, we're going to throw a planetary body unparsable exception, just saying we don't know what that thing is. So from there they can look at it, interpret it, and then just choose one of the available options, for example. Now we don't have this exception yet, of course, so let's create it. So if I do Alt and Enter, create class planetary body unparsable exception, do this, and we'll just say message. Actually, we'll delete this for now because we'll generate the constructor in a second. The point is we don't want to extend throwable, which is the default. Instead, we're going to extend the parse exception from java.text. Now I'm doing this specifically so I can show you a subtlety of exception handling with catch blocks, or multiple catch blocks rather. So here, let's create a constructor. Now it just so happens that parse exception happens to take this error offset. We don't need that for our purposes, so we'll just do something like this. We just want to pass a message saying what the issue was. We'll just call it message as well, maybe, to make it a bit better. And we'll just pass in -1 to say that we don't really care about this. It's a bit of an abuse of how to work with parse exception, probably. But I guess the idea of a parse exception from java.text is it's going to show you exactly where in the string the problem occurred. So that's why it's trying to use an index. But we don't really care about using parse exception properly. We just care about showing you what happens when you use subclasses of exceptions in the same catch block, or same group of catch blocks, rather. So if we click this, we get this underlined now, and that's because it's a checked exception. So we'll add the exception to the method signature to show that people need to be able to handle planetary body unparsable exceptions. We'll then jump back out to app, and we'll also call the method. So planetary body pb equals our utils class, remember, dot parse planetary body. And we're going to pass in sun, for example, first of all, just to check that the method works. So if we debug this now, F8, here we can see that method call, this parse planetary body method call worked, and we've got a planetary body back sun. That's fine, we'll just cancel that, so at least we know the method's working. And now let's put something in here which we don't have, like Saturn, and re-debug. F8 here, F8 again at this point, and when we do this, we end up in our parse exception block, which might be surprising because we're actually throwing a planetary body unparsable exception, not just a parse exception. But the point is, because our planetary body unparsable exception extends parse exception, so because this is a subclass of this, which is a superclass, and because in our catch block we're catching the superclass, or rather we're catching exceptions of type superclass, it means it's going to catch any exceptions which happen to be subclasses too. So because planetary body unparsable exception is a parse exception, that's why we end up here. So even though the explicit type of the catch that we're going for here is a parse exception, because planetary body unparsable exception is a subclass, this is what's actually caught here. So that's nice. It basically means that Java's exception handling works with the idea of subclasses as well, and the type system. Of course, there's a problem with this. Just play this off now. There's a problem with this, and it's basically what happens if we did this instead. So if this was the one that caused the error, then we'd still end up in this block. So whether it's this one that causes the error or this one that causes the error, we're still going to end up in this block. And that's because we're only ever catching the superclass type. So a way around that is to add another catch block. So we could try and do that. For example, here we could say, you know what, I'm going to catch the more specific subclass exception type instead. Sorry, not instead, as well as. Catch it here, and I'll say could not parse the planetary body, for example. And here where we would say could not parse the date. But you'll notice now that this is in red, and it says that this exception type has already been caught. And that's because the compiler is smart enough to know that parse exception is a superclass of planetary body unparsable exception. And because Java evaluates catch blocks in sequence, in order, it means that when parse planetary body throws out a planetary body unparsable exception, the first catch block it would try and match against is this one, and because planetary body unparsable exception extends parse exception, it would actually be handled by here, which means that this is now dead code. This is never going to get executed because Java's already caught the exception and dealt with it here. And if you're thinking now that the way to fix this is to shift the order of the catch blocks, then you're completely right. That's exactly the solution. So now here, because we're catching the more specific subclass first, and this catch block is evaluated first, it means that when this method call throws planetary body unparsable exception, it's going to be handled by this. However, when this method call is executed and it throws a normal parse exception, the superclass, it won't match against here, and it's the superclass catch block that's going to be executed. So let's just try that. So if we debug now, in this parse method, that's going to fail. So if we F8, we end up in this parse exception catch handler, because that was the exception type that threw. Okay, so play that off, and it'll say could not parse the date. If, however, we make the date perfectly legal, and then it's just this one that's not going to be any good, and throw the exception, and then repeat the debug, then we're okay, we have that date, that's fine. Then when we try and do parse planetary body with an invalid value of Saturn, it ends up in the correct catch block for that specific subclass. Printing out, could not parse the planetary body, play that off, look at it in the console, we can see it's handling it correctly as we expect. So the moral of the story here is when you're composing catch blocks, first of all, make sure that you understand the exceptions that are being thrown and whether there's any subclass relationships between them. And if there are, make sure that you order the catch blocks such that the most specific exception type is caught first, and the least specific, the most generic, therefore, exception type is caught last. Might seem complex at first, but you'll soon get used to it. It'll become second nature before too long, now that you know all about how to handle and deal with exceptions in Java.